Good morning, guys. Today we will be discussing our last tutorial, and try to cover up some of the important topics that are left in the course. So we will be starting off from the oscillators, right? So there are a lot of oscillators that are used practically in our everyday life. For example, if we have our PC or laptop, it will have an oscillator that will generate the clock. So one of the examples can be clock generation and laptop slash PC, right? All right, so what is the basic building block of an oscillator? Or what's the purpose of an oscillator? Is that you apply some DC input to this oscillator, and what it does, it gives you an AC output waveform, right? With different frequency. So the AC output can be a sinusoidal output. It can be a clock type output, right? It can be a triangular type output. So it depends on your need, which type of oscillator you are going to create. So basically what you do is you can generate your defined frequency based output of all the three types of natures of waveform. All right, so oscillators. Oscillators are basically nothing, but they are just an operational amplifier with a positive feedback. So I'm gonna say that oscillators are just op amp with positive feedback, right? The basic circuit of an oscillator or basic building block diagram of an oscillator would be something like this, that you have a Vn, it's a summation block over here, and it's going into an op amp which has a gain of A, and you are actually taking the V out from here. The feedback from here goes through a set of circuit which we call right now as beta, and that would be inputted back over here with the positive side, right? So whatever you input over here from V in, your output would be V out would be A, which is the amplification factor, times the V in, right? And on this feedback loop, if I try to figure out the voltage over here, that would be V feedback voltage, which we can say that equals to beta. What's the input? It's the V out input over here. So we can say that Vf is nothing but beta A V in, right? That brings us to a very important discussion, which is about A and beta. So there is A and beta, and it's called as loop gain of oscillator. This value would define the loop gain of the oscillator, right? So if you have something like A beta less than 1, for example, zero point 0.9 or something like that. So what will happen? Your oscillator will actually work, for example, if it's a sinusoid oscillator, but after a period of time, it will try to damp out and it will eventually be died out, right? Because you can just try to understand that with the value over here, that's when we multiply that less than 1, it keeps on dying out with every next output as an answer. Secondly, when we have the A beta greater than 1, if we have such a case, then probably in the start you would have not have any value, but eventually the oscillator will start to oscillate and it will keep on increasing The issue is with these two type is that they are unstable sort of oscillators, right? Whereas we would need a stable sort of generation of waveform with same amplitude, maybe like this or maybe like this in terms of the square nature, right? So this is what the issue is. So in order to have the stable output, we would always need that A B magnitude, which is the magnitude of what loop gain of oscillator should always be equal to 1, and the phase shift of the two combined phase shift should be equal to 0, right? This is our condition that should be met always in order to have a stable oscillator. And there is a specific name for these conditions. It's called Barkhausen criteria. All right, so yeah, so this is a basic circuit that you should know about the oscillator, and you would probably have the A and B value, and you can design on the basis of those two parameters later on. But first, this is the condition that you should know should be there. All right, so once we are done with understanding the basic phenomena of the oscillators, let us quickly run through the different types of oscillators that we have. So we have an RC oscillator, we have LC oscillator, we have crystal based oscillator, we have relaxation oscillators. Also, we have 555 timer IC, which can be used as oscillator, right? So the first three over here, the RC, LC, and the crystalline based oscillators, would give you a waveform in the sinusoidal nature, right? So we call them as sinusoidal oscillator. Whereas the relaxation oscillator is a type of oscillator in which you can create waveform, for example, if you want to create a square or triangular, right? So you can have the waveform like that, or for triangular part, you can have the waveform like that of an oscillator. 555 IC is also a timer IC that generates pulses, and it can be used as an oscillator as well. Right, so this is all the basic understanding of the oscillator and how does it work. In the next video, we will be discussing about the first type of oscillator, which is the RC phase shift oscillator.